Good morning, respected Chairman Sir, Principal Ma'am, teachers, dear parents, and my fellow friends. A bright and joyous welcome to the celebration of brilliance, SOLVIMANIA, a stage where numbers groove, logic dances, and creativity adds up beautifully.
Well, today is all about changing the way we see math, not as a subject to fear, but as a language of patterns, beauty, and imagination.
So sit back and relax as our talented students take you on a magical ride through the world of math in the most unexpected ways.
Our school is not just a structure, it's a nurturing ground, our home away from home, and a lighthouse guiding us towards knowledge and wisdom. Our school song reminds us of our values, roots, and our dreams. Let us now sing the school song together with pride in our hearts and smiles on our face. I would now like to invite the choir to lead us with the school song.
Let us celebrate the joy and praises of the school we hold so dear. Of the school that claims our respect, DWPS, surely be true. Stand, we will enjoy and pride, ever ready to proclaim. Stand, we will enjoy and pride, ever ready to proclaim. DWPS, we glory, proud we are to carry the name. DWPS, we glory, proud we are to carry that name. Service is our fearless motto, honor is our guiding star. Ever ready to recoup us where the steps are wandered afar. Time to see us falling apart, life may grow dull and cold. Time to see us falling apart, life may grow dull and cold. Still our cling to our affection, DWPS shall have our hope. Still our cling to our affection, DWPS shall have our hope. Still our cling to our affection, DWPS shall have our hope.
Now it's time for a special moment. I would like to invite Principal Ma'am on stage to bless the birthday stars. I would like to invite Abhilasha Ma'am from staff, Nivisha from PP1, R. Kritik from grade 7, and Yashwant from grade 10. We wish you all a very happy birthday from the DWPS family.
Happy birthday to you. Happy birthday to you. Happy birthday, happy birthday, happy birthday to you. May God bless you, dear. May God bless you, dear. May God bless and keep you. Happy birthday to you.
Thank you, Mom. Every great beginning deserves a warm welcome. And to officially set the tone for the event, I would now like to call Bhanvika on stage for the welcome address.
Good morning, everyone. With great excitement that multiplies exponentially, I warmly welcome our Honorable Chairman Sir, esteemed Principal Ma'am, respected teachers, dear parents, and my dear friends, to our school's Math Fiesta, SOLVIMANIA. Today, we have gathered to add joy, subtract fear, multiply knowledge, and divide success among all. This is not just an event. It is a mathematical journey where every problem becomes a challenge, every solution is a celebration, and every single equation tells us a story of logic and creativity. Let's align our angles of curiosity, calculate with confidence, and measure our minds against new ideas. Whether it's geometry that shapes our thinking, algebra that balances our thoughts, or data that graphs our growth, this day promises us to sum up the best of our mathematical spirit. So, together, let's make this event the true formula for inevitable success. Let the math magic begin.
Thank you, Bhanvika, for your warm words of welcome. The stage is now set and the journey begins.
We begin with grace, tradition, and hidden mathematics. Yes, you heard that right. Watch closely as geometry and symmetry are woven together into this classical masterpiece.
There's a rhythm in math, and math in every rhythm. Dance is created by defining space in time. Each posture is a geometric definition of space, and each movement is a calculated definition of time. Before creation was formation, the geometry. Today, we unfold a story not written in ink, but etched in angles, symmetry, and steps. Welcome to Nritya Ganitam, where numbers dance, the mathematics of dance. A straight line, a perfect curve, parallel lines, perpendicular lines, intersecting lines, a transversal, symmetry, line symmetry, reflection, rotation, shapes, a triangle, a circle, transformation, one shape to another, a straight line to a circle. Mathematics of time, clapping and footwork at interval.
Oh, that is absolutely mesmerizing. The stage has come alive with assertion and reason. Let's hear it again for our accurate dancers.
Time to meet the minds who shape the math we learn today. This role play brings to life brilliant mathematicians. Let's travel through time and welcome Varshit from grade 7, Devanshi from grade 6, Havish and Samyukta from grade 8 as they step into the shoes of mathematical legends.
I am Rama Gupta. I was born in 590 CE in Bimal, a city present day in Rajasthan. I was a prominent Indian astronomer and mathematician. I was known for my works Brahmasputra Siddhanta and Kandya Kandyaka, which significantly impacted the mathematics and astronomy. I credited developing the first formula for area of cyclic quadrilateral known as Brahmagupta's formula. My work on zero and negative numbers paved the modern algebra. I wrote more than 25 chapters and 1000 verses in it. I am considered one of the greatest mathematicians in ancient India. Thank you.
I am Aryabhatta. There's a pond filled with lotus flowers. Let me count it. 1, 2, 3. But there are some spaces which are empty. How can I count nothing? How can I write nothing? Yes, this nothing can be called zero or sunya. So let us write it. 1, sunya. Then 1, sunya, sunya. Then 1, sunya, sunya, sunya. each time the value grows tenfold. It is not only numbers which grow, it is also the space. What if the space had a form? Not to give others their value, not to count, but a force which makes numbers breathe. In heavens, the planets rotate in a circle, or Sunya can be the vessel of the unseen, from which a universe of numbers can be formed. This zero or Sunya helped to develop various concepts such as trigonometry, decimal number system, etc.
Nobody challenges me. I challenge myself. Hello everyone. I am Shakuntala Devi. You may know me as a human computer, but honestly I don't like the title at all because I've always believed that human minds are more powerful than machines. I was born in 1929 in Bangalore. My father discovered my talent at 3. By 5, I was solving college level math problems with no formal education. My love for numbers took me across the world, from India to London, New York, Rome. Now let me take you to Texas, 1977. At the Southern Methodist University, I was challenged to extract the 23rd root of a 201-digit number. Even the mighty UNIVAC 1101 computer took 62 seconds. I did it in 50, mentally. In 1980, the Imperial College London gave me two 13-digit numbers, 7686369 774870 into 2465099 745 779. I answered in 28 seconds. 18947 668 177 995 426 462 773 730. Am I correct? And that fiat placed me in the Guinness Book of World Records. In 2013, I was honored in Mumbai with a Lifetime Achievement Award for my contribution towards mathematics. I've written many books like Figuring the Joy of Numbers, Mathability, Awaken the Math Genius in a Child, Puzzles to Puzzle You, and many more. I just wanted to say every child that math is not your enemy, it's your best friend. I am Shakuntala Devi, a proud Indian, a passionate mind, and a proof that if you believe in yourself, the whole world will believe in you too. Thank you.
An equation for me has no meaning unless it expresses a thought of God. I'm Srinivasa Ramanujan and I was born on December 22nd, 1887 in Erode, Tamil Nadu. From childhood, I felt mathematics as an art, each equation as a masterpiece and each theorem as the universe. By the age of 12, I remember the cast synopsis absorbing thousands of formulas with no proofs. In 1903, I secured a scholarship at the University of Madras but lost it the next year because I neglected all other subjects in pursuit of mathematics. In 1909, I was employed as a clerk earning only 20 pounds per year. Despite that, in 1913, I wrote many letters to the renowned British mathematician G.H. Hardy. After many tries, he replied. He was amazed to see my methods. So in 1914, I moved to England. In Cambridge, Hardy and I collaborated forging the circle method and revealing deep surprising congruences related to partition functions and my method, which Hardy named the mock theta functions. I also discovered deep results in continued fraction and modular forms. In 1918, I was elected to the Royal Society of London. I was compared to great mathematicians like Carl Jacob and Isaac Newton. I was nicknamed the title, The Man Who Knew Infinity, due to my knowledge at the infinite series related to pi. Thank you.
That was fascinating. Our young stars truly brought history to life, showing that math was and will always be a human journey of discovery.
Now comes a fun-filled and inspiring skit by Dakshita and Divika. Did you ever meet someone who says, I hate math? Watch how the skit transforms that hate into love and maybe even genius.
Numbers on my books, numbers on the watch, numbers even on the cereal box. Math is scary. It's full of problems I don't want to solve. Why are there word problems? If I want words, I read a storybook. And why does everyone love multiplication? 2 times 5, 3 times 8. I say no times anything. I don't understand. Then something strange happened. My teacher showed us a math game. We played multiplication bingo, and then suddenly I shouted bingo. That was the first time I smiled at a math problem. Then I helped my little brother to cut a cake into equal slices. That's division. My mom said, wait, I used math? Me? A math hater? Then I found a trick to remember 9 times table with my fingers. Now I feel like a math magician. I even used math to beat my friend in a card game. I counted fast, and guess what? I started helping my classmates to solve puzzles. Now they call me a number ninja. Dear diary, I say something I never thought I would. I love math because math is not just numbers. It's smart thinking, it's funny games, it's everyday life. If I can become a math genius, anyone can.
What a powerful performance. It reminds us all the struggles with math don't mean failure. They're just the start to finding your genius.
Up next, we have a heartwarming skit set during an alumni meet, where old friends reunite, share memories, and realize that the one subject they always feared, math, is now part of their everyday lives. Get ready to smile, laugh, and relate. Presenting Math is Everywhere, an alumni reunion.
Hello everyone, welcome back to your school to this special alumni meet. I still remember watching many of you ran through these corridors full of energy, mischief and dreams. And today I see you all as grown, accomplished individuals. A doctor, an army officer, an architect, a chef. It fills my heart with pride. But I also know many of you are meeting your childhood friends after a long time. So, take a 10-minute break, get some refreshments and we'll all gather back here soon.
Wait, Rahul from class 10B? I remember you pulling the chair when one sits.
Sneha, my bad! I'm unable to recognize you without your biology textbook in your hand.
Hey, do you all remember Arjun, who failed the drawing test? And now he's an architect.
Ha! Now I get it. Math and design has made sense later.
Oh boy, look at him.
Mr. Math Professor?
Varun, right? Are you still carrying your calculator in your pocket?
And yes, I agree. I still love equations. Unlike the people who ran then.
Math was indeed haunting those days. Remember, Rahul used to cry before every math test?
Do you remember the dance we performed for the math event?
If sin square theta plus cos square theta is equal to 1 beta, then cos square theta minus sin square theta equals to cos 2 theta. 1 plus 1 equals to 11 नहीं होता बेटा. बाकी सब्जेक्ट्स में हम कुल बस मैथ्स में डब्बा गुल 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 गुल. मैथ्स में डब्बा गुल, मैथ्स में डब्बा गुल, मेरा मैथ्स में डब्बा गुल, मैथ्स में डब्बा गुल. Oh dear Newton Einstein, how could you find it good? मैथ्स में डब्बा गुल, मैथ्स में डब्बा गुल, मेरा मैथ्स में डब्बा गुल, मैथ्स में डब्बा
ना फोड़े कुछ घंटा समझ ना आए भयंकर है सिचुएशन विद क्वाड्रेटिक इक्वेशन अलजेब्रा ट्रिग्नोमेट्री टैक्सेशन मेंसुरेशन दिखने में पेशेंट नॉर्मल पर सीरियस है कंडीशन सिलेबस घोल के पीते एग्जाम में अंडा आता कब से बैटिंग कर रहे भाई फिर भी ना खुल रहा खाता मैथ्स में डब्बा गुल मेरा मैथ्स में डब्बा गुल oh dear Newton Einstein how could you find it cool मैथ्स में डब्बा गुल मैथ्स में डब्बा गुल मेरा मैथ्स में डब्बा गुल मैथ्स में डब्बा गुल
That was really nostalgic.
My lovely students, so you still remember math with fear and fun, huh?
Ma'am, they still tease me for loving equations.
And yet, you all use math every single day. Rahul, in the army, I heard while on the field you use coordinates, maps and angles in shooting drills. Am I right?
Yes, ma'am. Without math, we can't even plan an accurate mission.
Sneha, I wish to know, do you calculate the dosage, temperature and time during surgeries?
Ma'am, we can't miss the minute units. Almost every second. Precision is everything.
Arjun, what about angles, symmetry and geometry?
Oh, don't even ask, ma'am. Every blueprint is basically math with a pencil.
Rishi, what about the art of cooking? Do you incorporate numbers?
Ma'am, to bake, calculation plays a vital role. From ounce to grams, proportion to timing. It's all math with a dash of measurement.
And you, Priya?
Coding is logic plus math. Without math, computers are just boxes.
So maybe math wasn't your enemy, it was your hidden friend. It just took a while to recognize it.
Ma'am, do you remember how you used to teach angles with dance steps?
Yes, I remember, dear.
Can we refresh thinking of good old days?
Yeah.
Lines and angles. Nerdy by nature. Xavier, Rashim, you ready to rock? Come on. Lines and angles, angles and lines. Yeah. Get your groove on and I'ma get mine. Lines and angles and lines. Let me see that angle looking mighty fine. Check it out, my peeps. Lines and angles are a breeze, cause you know that right angles are 90 degrees. If it's less than 90, then that angle is a cube.
Kinda like a right angle got stepped on by a boot.
Here's another angle that I've got to introduce. If an angle's more than 90, then we call that thing obtuse. A straight angle is looking super flat.
It's 180 degrees.
Come on and stretch it out like that. Stretch. A reflex angle greater than 180. Here's the plan. Whip your arms around like this so you can do the Pac-Man. 360 degrees is a full rotation. Around the world and back to your original location. Hey.
Alright, let's do these angles. Here it is.
Right angle.
Right angle.
Acute angle.
Acute angle.
Obtuse angle.
Obtuse angle.
Straight angle.
Straight angle.
Reflex angle.
Reflex angle.
Full rotation.
Full rotation.
Nerdy by nature.
Lines and angles and lines. Get your groove on and I'ma get mine. Lines and angles and lines. Let me see that angle looking mighty fine.
Two lines on the same plane, what you call them? Can you tell they never intersect, yo? That means they're parallel. When lines meet at right angles, it's so particular. Like when I do the robot, yo, I'm on perpendicular.
Intersecting lines.
This is what you call it when they cross. When I cross my arms like this,
I feel like
I'm a boss.
He's a boss.
Alright, let's hit these lines. Here we go.
Parallel lines.
Parallel lines.
Perpendicular lines.
Perpendicular lines.
Intersecting lines.
Intersecting lines. Now rewind that one more time. Man, don't know when now. Let's go.
Right angle.
Right angle.
Acute angle.
Acute angle.
Obtuse angle.
Obtuse angle.
Straight angle.
Straight angle.
Reflex angle.
Reflex angle.
Full rotation.
Full rotation.
Parallel lines.
Parallel lines.
Perpendicular lines.
Perpendicular lines.
Intersecting lines.
Intersecting lines.
Oh!
Lines and angles and lines.
Yeah.
Get
Get your groove on and I'ma get mine. Lines and angles, angles and lines. Let me see that angle looking mighty fine. Lines and angles, angles and lines. Get your groove on and I'ma get mine. Lines and angles, angles and lines. Let me see that angle looking mighty fine.
Every time I structure a design, I owe my credit to you for teaching us the right concept, which in return fetches a blessing at our workplace.
We realized that some of the simplest lessons shaped our biggest achievements. Math is not just in books. Math is in life. Math is in us. Indeed, math is everywhere.
Yes, math is everywhere. I am really proud of you guys. Continue to be the best version of yourself. God bless you all.
Thank you, ma'am.
That was truly a beautiful reminder that math isn't just a subject, it's a part of life. From doctors to architects, from chefs to soldiers, math finds its way into everything we do. Let's give a big round of applause to our performers taking us down memory lane and showing us that math is everywhere.
We now present a thought-provoking skit by Hima Varshit, Yashwant and Bhavish from grade 10. Their story will explore the deeper connection between math, logic and the choices we make in life.
The most awaited final is down to the last over. Delhi Capitals scored 218 runs for 7 wickets in the first innings. In response, Chennai Super Kings are at 200 for 8. Yashwant is the only batter left. Now CSK need 19 runs from the final over to win their 6th title. The bowler? None other than Mitchell Starc, the death over specialist. Can Yashwant dominate him? Let's find out.
19 runs, 6 balls. It's finals. I can't mess this up. My team's victory is now in my hands. But the target is not that easy. Should I go big from ball 1 or play it safe?
Yashwant, breathe. You're trying to fight emotions with emotions. But today, let's use logic. And the statistics, the truth behind your story. Actually, every story.
Stats? How will numbers help me hit boundaries?
Because numbers don't lie. Let's look at your last 10 innings. Your total add up to 380. Let's divide it by 10 innings. Average is 38 runs per innings. That's your capacity. Now, let's look at what you repeated. You scored 53 times, more than any other score. That's your most frequent performance.
Okay, now what should I do in this last 6 balls?
According to your stats, you've hit 100 boundaries out of 300 balls. So you hit 1 boundary every 3 balls. And you have taken 200 singles in which you converted 100 into doubles with your smart running. So you can convert 1 double in every 2 balls. So now you have to hit minimum 3 boundaries to make it easier and leave no scope for dot balls. This is a stats-based plan. Smart, not desperate.
Thank you so much.
The strategic timeout is completed. Now, Yashwant on strike against Mitchell Starc. The first ball is a bouncer. Yashwant goes for a pull shot. Has he got the timing right? Yes, he has. It has cleared the boundary. Another quick one, full and straight. Yashwant flicks it off his pads. Races to a deep mid-wicket. He comes back for 2. He's quick between the wickets. Starc goes wide this time. Yashwant reaches for it. Cracked through the covers. That's 4 more. Yorker attempt. Yashwant digs it out. It rolls to long on and he's running hard again. Turns back for a second. He's too fast. The pressure is immense. Starc with a slower one. Yashwant picks it early. Lifts it high over extra cover. It drops just inside the rope. 4 runs, 1 from 1. This is it. 1 run to win. 1 ball to go. Yashwant has done it all so far. Starc steaming in. The crowd holds its breath.
You just made my chase feel winnable.
You all saw him freeze under pressure. But he's not alone. Every one of you faces pressure. In exams, decisions, dreams. We panic, we doubt, we guess. But like I told him, don't go wild. Go wise. Understand your patterns, trust your consistency. Because in life, just like cricket and in math, it's not about playing every shot. It's about choosing right formula at right time, backed by right numbers.
It's a full toss on the pads. Yashwant clips it towards mid-on. They're running. The throw comes in. It misses. He's done it. Yashwant finishes it off in style. CSK wins their 6th title, and this final will be remembered forever.
I made my team win just because of you.
Look, statistics isn't about numbers. It's about knowing
yourself.
Hey, I gotta help others too. Bye.
What a powerful performance. Hima Varshit and Yashwant beautifully reminded us that math isn't just about numbers. Let's applaud their thoughtful efforts and a strong message that added so much depth to SOLVIMANIA.
Let's celebrate math not with fear but with wonder and excitement. And now for the final performance of the day, let's welcome the dynamic dancers of Grayton as they bring math to life with rhythm, energy and joy.
Just stop. I already feel like I'm drowning in numbers. Every time I open the textbook, I see formulas attacking me. Algebra feels like a foreign language. And geometry? Don't even get me started. Those angles are out there to get me. My hands sweat when I hear the word equation. And when someone says to find x, I want to say, no thanks. Let it stay lost.
And when mom starts asking questions, my brain, it starts buffering, I don't know why. My mind goes blank like a whiteboard after the duster attack. I even tried talking to the calculator, but it just kept saying error. Just like my life. And math.
Confusion ही confusion है, solution कुछ पता नहीं. Solution जो मिला तो साला question क्या था पता नहीं.
दिल जो तेरा बात बात पे घबराए, दिल पे रख के हाथ उसे दिल फुसला ले. दिल इडियट है, प्यार से उसको समझा ले. होठ घुमाओ, सीढ़ी बजा के कौन भैया ऑरेंज में. अरे भैया ऑरेंज में. अरे चाचू ऑरेंज में. अरे भैया ऑरेंज में.
फेवरेट सब्जेक्ट है. मैथ्स में रूल्स नहीं है, सिर्फ जादू. तो तैयार हो मेरे बेस्ट फ्रेंड मैथ से दोस्ती करने के लिए?
दो मुर्गी तेरी, दो मुर्गी मेरी, चार तेरे मामे की. 7 सुर में जो 3 ताल मिले, धुन बने गाने की. दुनिया है सारी नंबरों से बनी, बक्से से बाहर निहार. हम नजर अभी कीड़े किताबी, टेंशन मत ले यार. बोलो बेटा 1 2 3 4. तो डरना क्या मेरे यार, बोलो बेटा. तू टेंशन मत ले यार.
Mathematics is not meant to be feared. It is meant to be explored with curiosity and celebrated with pride. It's not just getting the right numbers. It's about learning to think, to question, and discover. Let's shift the way we think about math, not as a challenge, but as a chance to think creatively, question boldly, and discover endlessly. So from today and every day forward, let's promise ourselves to embrace math with open hearts, open minds, and fearless joy. Thank you.
What a grand finale. Great 10 just reminded us that math can move, shine and inspire. Let's give them a huge round of applause for a fantastic performance.
Behind every successful event, there is a guiding light. Someone whose vision, support, and encouragement shapes the way forward. Her presence today adds meaning to our celebration, and her words always leave us inspired and energized. It is with great respect and joy that we invite our exceptionally vision-oriented Principal Ma'am, Dr. N. Janvi Reddy, to address the gathering and share her thoughts on this special occasion, SOLVIMANIA. Let's welcome Ma'am with a thunderous rounds of applause.
Thank you, Virat. Respected Chairman, sir, dear parents, my team and beloved students, good morning. Welcome to Math Solvimania, a math fiesta. Teachers, can I request you, please, for today you can sit. You are objecting the parents' view. Please sit down. Have your seats. Thank you so much. Please. Dear parents, my students did a lot of hard work to put on this show. Please, I want you to give big round of applause for all my children. Thank you. The prime purpose of conducting or organizing Solvimania is to foster awareness in the students that maths is not only the subject for examinations, but it is a lifelong skill. I understand maths is woven into our daily lives beyond the textbooks. And we know many students are intimidated by math, so often they choose science stream because of the fear towards math. Hope majority of the parents will accept with me. Because I myself was once one of those students. Because of that, even I took science stream instead of maths. Later, when I progressed in my life, I realized maths is quite easy subject. Only we need to know when, where, and how we need to use appropriate formula to solve the problems with an ease. The same applies to our lives also. If we know how to tackle the challenges, we can give accurate solution for the challenges. After recognizing many students having fear for math, so we have conducted many competitions for this Solvimania to demonstrate that math is relevant to many fields, along with performance of arts also. At DWPS, our main focus is to help students to view maths not with fear, but with passion, curiosity, and appreciation. I wish all the dip sites from today onwards to begin with practicing positive affirmations about maths. I like maths, so that you can develop love towards math subject. With this mindset, you can empower to become a true math magician. So my dear dipsites, from today onwards, I want you to play with the numbers and to become a true math magicians. Thank you.
Thank you so much, Principal Ma'am, for your kind words and constant encouragement. Your guidance continues to inspire us to learn with joy, lead with purpose, and to grow with confidence.
As our journey to the world of numbers, patterns and performances comes to a close, it's time to express a heartfelt gratitude. To thank all those who made SOLVIMANIA a grand success, I now invite Megan on stage to deliver a vote of thanks.
Good morning, everyone.
What a wonderful journey it has been today. SOLVIMANIA truly showed us that math isn't always about solving numbers. It's about fun, creativity, integration, and so much more. On behalf of the entire team, I take this moment today to thank everyone who made today's celebration a grand success. A heartfelt thank you to our chairman sir, principal ma'am and our Stella school management for their constant support and encouragement. To our teachers, thank you for your guidance and motivation through every performance you have seen today. To our amazing students, the dancers, actors, singers, model makers and speakers, you didn't just perform maths, you brought it to life, made it fun and made it interactive. To our dear parents, thank you for being with us, cheering us on and making this event a grand success. We truly appreciate the time and support you have dedicated to make this event a grand success. To our supporting staff, thank you for being with us and making a silent support that kept us going. And let's not forget the very meaning of SOLVIMANIA, that math is not to be feared, but enjoyed, explored and celebrated. Thank you and have a great day.
Dear parents, thank you so much for your presence in your busy schedule also. I don't want you to leave after this performance. Please, inside the exhibition has been arranged. Students have prepared models. I want each and every parent to go and visit the exhibition and see all the models. Thank you.
Good morning, sir. I am Banvika from class 10 Lilac, and my model's main motive is to show you how we can use math in real life. Every student gets the doubt, where can I use Pythagoras theorem, where can I use triangles in real life? And my answer is through geometry in cities. In my model, I have used geometry everywhere, from the layout of the city to building individual houses. So in the layout, I have mainly used a hexagonal layout, and this was introduced by Sir Alistair Cockburn, who is an American software engineer, and he first designed this layout when he realized that a hexagon can be covered on all 6 sides by other hexagons. And this in such a layout can be very beneficial for the government and the people. The government because it uses less resources, like it reduces the length of the roads, and the people because each resident can get a proper amount of land without it being congested. So this makes it a win-win situation, making it very optimistic to use geometry such in layouts of cities. And I think such buildings like our previous school are always the best example to show how we can use geometry in real life, because such buildings are beautiful complex designs combining squares, rectangles, cubes or cuboids, and they show how we can combine shapes to form a better shape which can accommodate people better. We can also use other tools like area and circumference, in this case for a circle using pi. Pi's value is approximately 3.14 or 22 by 7. We can calculate the area of, for example, a flag hoisting with the formula pi r square. If we take the radius to be about 50 meters, the area that we get will be a result of 7,850 meters square. And this is the amount of land that we have to hollow if we want the hoisting to be stable. And if we want to build barricades for security purposes, we have to find the circumference. The circumference can be given by the formula 2 pi r, and when we calculate it for the radius 50 meters, the result will be about 314 meters. So that is the distance of barricades that we need for proper security. So math is never avoidable in life. Math is always useful, and whenever we look at a new building or a park, I think the first question that arises should be how did they design it? Thank you, sir.
Very nice explanation.
Thank you, sir.
Explain these different areas.
Yes, sir.
One is circumference, the area.
Yes, sir.
So, defense also we need to explain.
Yes, sir. Like if we want to create, like for helicopter landings, we need a proper area for the helicopter land without people getting hurt when they land and stuff. So we have to find the radius. We can use the radius as the fan length for the helicopter, and we can take the radius as the radius for the land where it's going to land. So that area should be like restricted so people don't get hurt.
So it has a vast application.
Yes, sir.
Very good.
Thank you, sir.
Good morning, everyone. My name is Dhruvan from grade 7. Sir? Good morning, everyone. My name is Dhruvan from grade 7 Tulip. I present you a project on temple crowd management system. Crowd controlling is a very difficult task, especially in places like India where the population is very high. So my project is to create an efficient crowd management. Mathematics has been a foundation for ancient Indian temple architecture. From geometry to astronomy, every temple showcases brilliant use of math in planning, design and construction. The main idea is to send a certain amount of people at a time for easy crowd management. In India, there are so many famous temples, and we have seen temples with full crowd, and some of them face stampedes too, just because of poor crowd management. I have chosen the Ram Mandir temple in Ayodhya. It is a 3-story temple constructed in the traditional Nagara style. The length of the temple is 380 feet. The width of the temple is 250 feet, and the height of the temple is 161 feet. The temple was constructed in an area of about 2.7 acres. The length, area and volume calculations help determine the size of walls, rooms and buildings. The angles and shapes are used in roof design, arches and domes. Also, there is a special feature about this temple. On Ram Navami, the temple features a Surya Tilak event during which the sunlight will illuminate the forehead of the Ram Lala idol for about 2 to 3 minutes, with the light entering at a 90 degrees angle. Now let me show you the working of this model. Here there is one sensor, and here we can see a display and this sensor will detect the movement of the people going inside, and here we can see it. So here we can see the temple number increasing. The number is increasing, and then after 10 the gate will close so that no more people can't go inside, and after 10 seconds the gate will again open. And the materials used for the working of this are motherboard, breadboard, servo motor, display and ultrasonic sensor. Thank you.
So how it will sense? It will sense only the population or people who
Yes,
are
sir.
entering, or
Here,
any machinery also will it count?
sir, here when this sensor detects the movement, it will send the signals to this display so that it will display 1, 2 like that, and then after 10 the gate will close. After 10 it will be connected from here and it will be closed, sir.
Very good.
Thank
Nice
you, sir.
explanation.
Thank you, sir.
Good morning, sir. My name is Vishwak Sen. So in front of you today I have two projects. So one is Voyager V and one is Pongomatics. So I'll start off with Voyager V. So it's a working satellite model. So it sends and receives messages. So it will be sending, as if now it's sending Earth's coordinates in the universe. So when we text back a message like hello or hi, it turns on an LED indicating that a message has been received. Just give it a second, sir. There. So this uses applications of trigonometry and kinematics. Basically kinematics is for angular momentum and trigonometry for calculating ratios. This is Pongomatics, a game which I have created using the applications of trigonometry, coordinate geometry and kinematics, sir. So basically it has an embedded gyroscope in it, so it can calculate the angles and move the paddle around. Like to have your demo, sir.
Sir, gaming?
Just movement, sir.
Movement, okay.
Concepts. So addition and subtraction is a fundamental arithmetic operation. Addition combines two or more numbers to find its sum. The numbers which we add is called the addends. Whereas subtraction takes one or more from a number to find its difference. The number from which the other number is subtracted is called the minuend, and the number which is being subtracted is called the subtrahend. Now let's see how does this tool works. So this is the frame of the abacus. This is the divider, these are the rods and these are the beads. So there are two parts of the abacus. So this is the lower deck and this is the upper deck. So in the lower deck there are 4 beads on each column, and in the upper deck there are 1 bead on each column. So one upper bead is equals to the number 5 and one lower bead is equals to the number 1. So now let's see how do we do addition on abacus. So let's see how do we do 5 plus 3. Can you guess what is 5 plus 3? 8. Okay, so let's see how do we do that on the abacus. So if we add 1 upper bead it makes 5, and if we add 3 lower bead it makes 8. So we can conclude 5 plus 3 is 8. So now let's see how do we do subtraction on abacus. So let's do 4 minus 3. Can you guess what is the answer?
1.
Yes. So let's do it on abacus. So if we add 4 lower bead it makes 4, and if we less 3 lower bead it makes 1. That's how we do addition and subtraction on abacus. So by summing up we can say that abacus is an ancient tool, but it gives us an ample opportunity to learn the concepts, increase our focus level and use in our day-to-day lives. Thank you.
God bless you.
Good morning, sir. My name is Preeta from grade 7 Tulip.
and my topic is mathematics in oceans. Wondering where is maths in oceans? Yes, of course it is there in oceans. Calculating the depth, calculating the area and volume. For example, I'll show you this. See, the laser light is going down and it's coming back. So the time it's taking is 3 seconds and the length is 1500 meters of this laser lights. So 1500 into 3 seconds is 4500 meters divided by 2, that is 2250 meters is the answer. Finding the area. Ocean, the Earth's surface is 510 million square kilometers and it is covering 70%. 70% of 510 million square kilometers is the area. So finding out the volume. Area is 357 million square. This area is 357 million square. So this should be divided by the distance to find out the volume, but I cannot tell you because there is different depth in different oceans. Some is deep, some is less deep. So finding out the ocean pollution. I am doing this. It is creating waves. This is the wind. For example, for wave it is moving up till certain level. So this is the height. So finding out the ocean, this water is moving every time. It is carrying the pollution. Once I throw pollution, it's going and gets there. It cannot come out of there. This example is great patch of garbage pollution. It's a huge patch of garbage and it's twice the city of Texas in USA. So once our pollution gets there, it cannot move. Only pollution will be there. Buoyant and buoyancy. What is buoyancy? Add water in hot milk. It will rotate and you mix it. Of course the water will rotate, right? That is called as buoyant and rotation. Something is light, something is heavy. Coffee is heavy, water is light. So for example, equations we understand to find the pollution. HO is the height of the water. WO is the width and VO is the volume, how fast the ocean wave is traveling. For example, from here to here 1 meter it's taking 0.2 seconds for the wave to move. So for 5 meters it is 1 second. So if we know HO, we know how deep our net should be. If you know WO, we know how wide it should be. We know VO, how fast we have to drag the nets with our ships to catch the pollution. So we are creating a problem ourselves. There are equations trying for more than 200 years. So why do we need these equations if we don't throw plastic in the first place? We don't need these equations. We don't need to carry our ships till there, catch the pollution. We don't need anything. So whenever you go to an ocean, think that, make sure that you don't throw pollution there and think that there is also maths in ocean. Thank you.
Good job.
Thank you, sir. Thank you.
Good morning, sir. Good morning, ma'am. I am Mahana from Grade 9 Lilac and these are my teammates. I am Somya.
And I am Arya.
So today we are here to present our research on the topic math and technology.
So because of growing advancements, maths plays a crucial role in various backgrounds such as medical imaging, cryptography, GPS navigation, financial modeling, etc.
Absolutely on point, Arya. Including all of these vast areas of technology, there is another topic which is dominant in today's technology and which has always been important in keeping our daily life smooth. It has always alarmed us with the probability of heavy rainfalls and the changing temperatures in our area. It is the weather forecasting.
Yes, Somya. Weather forecasting is indeed a very important aspect in our day-to-day technology. And guess what? Math is used in weather forecasting as well. The numerical weather prediction models, these use different equations. For example, the conservation of mass equation, the second law of motion of Newton, all of these equations are used in the numerical weather prediction models to predict the weather patterns.
So along with NWP model, discretization also plays an important role. Our atmosphere is divided into 3D grids and equations are solved according to the grid. It changes according to the temperature and pressure. After this, weather forecasters use a technique called calculus.
Calculus, especially derivatives, helps in predicting the atmospheric variables which are essential for weather forecasting. And how can you forget about MOS? Model Output Statistics. MOS helps in combining the output of statistical relationships with weather numerical models, which gives a better forecasting result, especially near the Earth's surface.
Yes, Soumya. So as we know that NWP models give a variety of weather predictions. So to give the accurate prediction of the weather, we use ensemble forecasting along with supercomputers which simulate all the weather patterns to give the accurate measurement.
Wow, that's indeed a lot of maths in STORM. I never knew that maths is used in weather forecasting as well.
I agree with you, Arya. Maths responsibility in our daily life has clearly increased. No wonder our teachers advise us to solve math as much as we can.
Yes, Soumya. And at this note, I would like to appreciate the role of math in our day-to-day lives. Thank you.
Hello everyone, I'm T. Shenika of Grade 4 Tulip. Today my SOLVIMANIA project is My Math Body where science meets numbers. Have you ever wondered how a doctor tracks your growth or how the wax sculptures are made at Madame Tussauds? Yes, accurate body measurements is the mantra. But today, most importantly, I'll be telling how a doctor tracks your growth by using height and weight for skeletal developments and overall growth and BMI for malnutrition and obese. The doctors use the WHO growth charts, that is World Health Organization, to indicate a child's growth compared to other children of the same age and sex. We have different growth charts such as height for age girls and boys and weight for age girls and boys. We have to interpret a growth chart. If you are below 3rd percentile, you are severely underweight, stunted or wasted. If you are 3rd to 15th percentile, you are underweight or mildly stunted. If you are 15th to 85th percentile, you are normal growth range which is healthy. If you are 85th to 90th...
You might also get a doubt, sir. How do satellites stay in orbit? Here we use these formulas from the physics. Physics is nothing but applied maths, sir. Formulas like Newton's law of gravitation helps to the satellites to stay in orbit, sir. We also use signal transmission waves from geometrical math, where how data is sent from one communicator to the other satellite, to the other communicator, where the other person gets the messages, sir. This is how the math is used in satellites, sir. Thank you, sir. Thank you.
Good morning, Mom. So today we're going to talk about the mathematical vision of astronomy. So we're going to talk about how the stars born till how the stars die.
You might think math and stars are interconnected, but math actually helps scientists understand the stars better.
So first let's start with the average star. It all starts in the stellar nebula. Then with enough mass it turns into an average star. When the fuel runs out, it turns into a red giant, and then planetary nebula. When the outer layers drift away, it turns into a white dwarf.
For the massive star, the story gets more explosive. It also starts as a stellar nebula, but gains much more mass and becomes a massive star. Later on, it turns into a red supergiant, burning fuel furiously for billions and billions of years. When it can't support itself anymore, it bursts into a powerful supernova. Later, what's left is either incredibly dense and fast-spinning neutron star, or if it is actually massive enough, it bursts itself into a black hole, where the gravity is so strong that even light can't escape.
So let's now talk how math helps. So scientists use many methods like luminosity to collect the star's brightness. So they even calculate many formulas for calculating the star's mass. Luminosity, that is 4 pi r square. Here's the formula, Mom. 4 pi r square constant t to the power of 4. This is a huge formula and it calculates the star's brightness. Now we have two methods. One is the stellar parallax.
Scientists use stellar parallax to measure the nearby stars. They measure the sudden drift of the star when this Earth moves around the sun. The small change in angle is known as the parallax angle.
Now let's talk about the standard candles. It is also a method to calculate the distance between faraway stars. It uses a different kind of star known as the Cepheid variables. Those are the stars that gradually get brighter and dimmer. Their brightness pattern tells us their true brightness. This is first found out by Hernita Swan in the early 1900s.
So, Math actually helps scientists predict the future of the star and model the past. They can even trace how iron, carbon and oxygen are formed using stars, the planetary life building blocks.
So the next time you look up at those beautiful stars, think that math helps us quietly and calmly behind all that beauty. Thank you.
While on a road trip, have you ever wondered that why every single building, tower or a bridge is assembled with the help of triangles? Don't worry, I, Nidhi from grade 9 is here to clarify it. But before moving on further, I would like to show you a small experiment. So here we have two bridges made with the help of paper. One has a zigzag pattern and the other one is flat. Now let us test the holding capacity by placing these boxes on them. As you can see, the flat bridge cannot resist the weight of the object, whereas the other one can hold it easily. This is because compared to any other shape, triangles are the most resilient one. When a load is applied on a triangle, the force is distributed evenly along the side, with two sides experiencing compression and the base undergoes tension, and thus minimizes stress at any of these points and help the structure to maintain its integrity. Did you know that triangles are considered one of the strongest shapes due to its inherent strength and stability? By using triangles for structures, we can create them very strong and stable while using less materials. Unlike any other shape, triangles maintain their form under pressure, which prevents destruction and collapse, which is crucial for supporting heavy loads in structures such as roofs, towers or buildings. By incorporating triangles into design, engineers and architects can create structures that are strong, durable and capable for withstanding external forces such as wind, gravity, etc. Moreover, the use of triangle enables the creation of strong structures and efficient use of materials. A triangle shape enables the creation of lightweight yet robust structures, which can lead to cost saving and easier construction process. Here is a bridge made with the help of ice cream sticks in such a way that it can be destructed into triangles. You didn't get it, right? This point is actually an interesting fun fact about triangles. Any polygon like square, rectangle, septagon or octagon and many more can be split into triangles. I know this is something new you have heard, but polygons are formed with the help of triangles. This phenomena is known as triangle polygonation, and this can be implemented as circles too. Here are a few famous sites throughout the world where the phenomena named triangulation is observed. The phenomena where triangles are used for construction. And with that, we come into conclusion, and I would like to say that without triangles, modern engineers would fall apart literally. That's it for today. Thank you.
Good morning, sir. Good morning, ma'am. Today, I'll explain the theory of probabilities through a famous casino game called the roulette game. So, if you have went to the casinos, you would...
What is the game name?
Casino game, the roulette game.
Roulette. Okay, roulette, yeah.
So, in this, what happens is that basically the wheel is it's spinning, and we have to throw the ball, and you have to place your bet on a particular number. So there are three ways on which you can bet a number. One, you have to choose one particular number. Would you like to choose? 3, 2, 1, go. The ball has landed on the number 7. So, in mathematical terms, probability can be calculated by the number of favorable outcomes by the total number of outcomes. So, you have chosen the number 1 out of all the 10 numbers. So, your probability will be 1 by 10. And there's the second way. You have to choose between the colors. There is the color red and the color black. If you choose the color red, your probability will be 5 by 10 because there are 5 colors of red and 5 colors of black. Okay. Would you like to try red or black?
I'll go with black.
Okay, black. So the ball has landed on the color black. So you have officially won. And now the black, there are 5 colors. So your probability was 5 by 10. So there's 50% chance of falling on the color black, and you have won. And now there's the third way. You have to choose between an even number and an odd number. Would you like to try?
Odd number. Is an odd number?
Odd or even number?
Odd. Go with an odd.
Okay. The ball has landed on an odd number. So the probability of the ball landing on an odd number is 4 by 10. So you have a 40% chance of landing on an odd number and 40% chance of landing on an even number. But why not 50%?
That's what exactly my question was. Why not 50%?
Would you like to have any guesses?
You can explain?
Yeah, so 0 is the answer. 0 is neither considered an odd number nor an even number.
Okay.
So that's why the probability of even numbers and odd numbers is only 40% chance.
But again, there are 5 odd numbers, right?
Yeah, 5 odd numbers.
5 out of 10?
Yeah, 50% chance. But not technically though, because 0 is neither considered an odd nor an even.
That's fine.
So
Even if it excludes 0, then again we do have 5 numbers, right? Odd numbers.
Yeah.
5 odd numbers.
But,
And if you are excluding 0, then it should be 5 by 9 numbers totally.
yeah, but there's not an equal chance of all the 3.
Absolutely. But again, the 40% may not be the right thing, if, in my view. Because if you say 40%, then it should be 4 out of 8
Yeah.
or 10, right?
Yeah.
But
Yeah.
here we are having 1, 2, 3, 4, 5. If we exclude 0, then we'll be having the 9 numbers. Then the probability of getting an odd is 5 by 9.
Yeah.
Okay? 5 by 9, which is more than 50%. But the probability of getting even is 1, 2, 3, 4. That will be 4 by 9.
Yeah.
Right?
Yeah.
So that will be less than 50%.
But 0 is still considered a number.
Yeah, if you consider 0 still consider number, then 1, 2, 3, 4, 5, 5 by 10.
Yeah.
Then again it will be 50%.
Yeah.
If you consider the even numbers, 1, 2, 3, 4, 4 by 10.
Yeah.
For the even it will be 40%, for the odd it will be 50%.
Yeah.
Right?
Yeah.
You got confused. So for the even number, yes, you are absolutely right. The probability is 40%.
Yeah.
But for odd number, the probability will be
50%. So there's the 10% chance of landing on a 0 number.
Zero.
People usually go with odd numbers or even numbers because they have more chances of winning.
You're right.
People who would like to test their luck or have got nothing to lose, they choose the number 0.
And one more small correction is, okay, yeah, anyway you choose the example of the roulette which is played in the casino.
Yeah.
Right? Okay. Here we are talking about only that probability was 0 to 9, which is 1 by 10.
Yeah.
But in reality, the roulette will be 0 to 35.
35, yeah.
But it will be difficult for you to demo this.
The man, yeah.
That's the reason you took a subset of the numbers and then demonstrate.
Yeah.
But the concept is really good.
Thanks.
Concept is good.
Thank you. Thank you.
Nice one.
Niharika's parents, 9.
Nice.
Yeah, I've heard. Thank you.
Nice.
Thank you.
Hey everyone, we all know that India is a land of farmers and we are here to show you how every step of farming needs math.
Welcome to our model Smart Farming with Math, where every liter, every meter, every rupee is carefully calculated.
Whether it's planning land, saving water, or selling crops, math helps farmers grow smarter.
This is the miniature project that we have done. This is the miniature project that we have done for explaining math in agriculture. Let's start with land. For example, the wheat field is 30 meters long and 20 meters wide. So to know how many seeds to buy, the farmer needs to calculate the area, that is 30 meters into 20 meters, which is length into width, which equals 600 square meters.
Now to fence the field and protect it from animals, we use perimeter. Perimeter is equals to 2 into 30 plus 20, which is 100 meters long. Without math, the farmer may buy too much or too little fencing. So math helps in reducing waste and save money.
Water and irrigation, measurement and volume. Let's say this tank holds 1500 liters of water. Each square meter needs 4 liters of water daily. With 600 square meters, 600 multiplied by 4 is 2400 liters of water daily, which means this tank needs to be refilled twice a day.
Also, we measure the irrigation pipe using meters. For example, if we need to lay pipes across 320-meter fields, we need 3 into 20 is equals to 60 meters of pipe. This is how measurement and volume can help manage water efficiently.
Now comes the harvest and the selling. So if 1 square meter of wheat gives us 2 kg, then a 600 square meter field will produce 600 square meter into 2 kg. That will give us 1200 kg of wheat. So let's say that wheat sells at 22 rupees per kg, then the total income would be 1200 kg of wheat into 22 rupees. That will give us 26,500 rupees. Thank you.
Guys, my grandma was on a video call from the village and suddenly the call dropped. She froze like this and now she looks like a confused emoji.
Dude, just blow the phone to refresh the signal. That's how I fix it.
Yuan, that's not how signals work. This isn't a hot cup of tea.
Exactly. When you make a call or use the internet, the signals travel all the way to the space to a satellite, then comes back to the Earth.
Wait, what? So you're saying that my hi grandma goes all around the world before she hears it? Dude, this is some kind of a lag.
Actually, there's serious math behind all this, like angles, distances, coordinates, signal speeds, and etc.
Maths? Maths here too? So you're saying me that maths is up there flying? Why can't we just leave maths on Earth?
Nope, whether it's Earth, Mars or satellites, math is everywhere.
And we have built a project to show how this all works. How math helps satellites talk to our phones, laptops, TVs and etc.
Math is very important. Without accurate calculations, satellites could either go out of orbit or send signals to the wrong places sometimes.
Algebra and signal speeds are used in calculating the time taken for signal transmission. And even a small delay in this may affect the video or audio calls.
Coordinate geometry is used in locating places. X, Y and Z coordinates are used to locate places on Earth.
Data transmission and statistics are used to shrink file sizes so that more data can travel faster, and also fix and detect signal errors so that the formulas can be proper.
Geometry and trigonometry are used in the positioning of the satellite. To calculate this, we will have to use the formula of tan theta is equal to height by distance. So basically, we are calculating the angle of elevation. By calculating this, we will know how to place the antenna so that it receives and transmits the signals correctly.
To sum up, satellite communication is not just a technological marvel, but a brilliant example of math in action. Math helps us connect with the world.
Hope you liked our project. Signing off, Akshay.
You won.
Abhinav.
Gayatri.
Thank you, Mom.
Good morning, ma'am. I'm Tanvi from grade 9A, and today I'm here to present my model making on the importance of triangles. So here you can see there are many structures here. So a triangle is a polygon with 3 sides and one of the strongest and stable shapes found in both nature and human-made structures. A triangle is also important because it distributes the weight evenly across the 3 sides, which prevents bending and collapsing when force is applied. So this ability helps builders and engineers to make structures strong and durable. So these are some of the structures where triangles are used. So the first one is the bridge. So in the bridges, you can see the triangular trusses. It helps to support the heavy loads of cars and trucks passing by. Next is the roofs of the houses. The roofs are made up of triangular frames to withstand the weight of heavy rain or snow during harsh weather also, to stay strong. Coming to the rockets, the nose cone of the rocket is often triangular because it helps to minimize the air resistance or the drag as it passes through the atmosphere. Next is the boat. Triangular sails are used because it offers excellent aerodynamics. It helps to cut water smoothly and to improve the speed. And next, in the geodesic domes, triangular sections are used here to build a lightweight building and also to have a strong, stable. Okay. Coming to the satellite dish, in the satellite dishes, the internal frame of the satellite dish is also triangular, which gives support for it and also to receive the signals accurately. So yeah, in conclusion, I say that triangles play a crucial role in many fields due to its properties in architecture, engineering, art and design, and etc. And so yeah, in 3 shapes, the triangle manages to be strong, smart and stylish, and that's why it makes it one of the important shapes in the world. Thank you.
Good morning everyone. I am Javerian as from grade 3 Lilac. I present before you a working model of solid shapes. A solid shape or a figure has 3 dimensions: length, breadth and height. This model project is developed by small electrical devices such as battery, LED light, buzzer and some wires. Before we start the model of the project, I would like to explain you about the face, vertex and edges. For example, this is a cube. This flat surface is called a face. To a line where 2 faces meet is called an edge, and a point where 2 edges meet is called a vertex or a corner. Now with the help of these 2 metal wires, we will know the name and the specifications of all the shapes. This is not a cylinder. This is not a cone. This is a cube. Cube has 6 faces, 8 vertex and 12 edges. Let's go with the next shape. This is not a cylinder, a cone, cube. It is a cuboid. Let's go with the next shape. It is not a cylinder, a cone, a cube, a cuboid. It is a sphere. It is a cylinder. Cylinder has 3 faces, 0 vertex and 2 edges. Let's go with the last shape of our solid shapes. This is not a cylinder. It is a cone. Cone has 2 faces, one vertex and 1 edge. Conclusions. We use shapes in our daily life. Shapes are everywhere. Dimensions help us to visualize and understand shapes better. So understanding characteristics of shapes from a young age makes math easier. Hope you all liked my project as I made with my parents. Thank you.
Good morning everyone, my name is Sohas. I am studying grade 7 Lilac. Today I would like to discuss on the topic Math in Weather. Mathematics is the backbone of the weather modeling, enabling the meteorologists to predict the atmospheric behavior with increasing accuracy. First, understand how the atmospheric conditions are calculated. Coming to rain, I am sure that everyone has this question on how the rainfall is calculated. I always wonder how it would be calculated until I researched it. The rainfall calculation involves the amount of the precipitation that falls over a specific area during a given period. Read the amount of the water collected in the gauge, which is usually measured in millimeters or in inches. Now let's look in the topic anemometer. Wind speed and direction are calculated using various instruments and techniques. An anemometer is a device which is used to measure wind speed and direction. The cup anemometer calculation measures the number of the rotations of the cup per minute, RPM or seconds. It measures 100 RPM. Wind speed is equal to 100 RPM into 0.1 meters per second per RPM is equal to 10 meters per second. Now let's look into the topic heat to cold measurements. Heat and cold are measured in Celsius, which is used for the scientific researches and applications. Fahrenheit, which is used for the scientific researches and applications commonly used in United States. Kelvin, which is used for the scientific researches and applications, particularly in physics and chemistry. We need to select a thermometer used for high temperature ranges, such as a digital thermometer or a thermocouple. Ensure that the thermometer are calibrated and accurate for the temperature ranges being measured. To summarize, math plays a crucial role in the weather forecasting. Math is also going to play a vital role in the real world also. For example, better decision making in such industries like transportation, emergency management. Math is also going to predict long-term climate patterns, which informs policy and decision-making related to changes of the climate. Hope you all find my model helpful and interesting. Thank you all. Have a nice day.
Very nice. Very nice. Your name?
Suhas.
From?
7th.
Very nice. Thank you so much.
You're welcome.
Very informative.
Good morning, ma'am and sir. My name is Sai Suhas of Grade 8 Lilac. Today I am going to tell you about a spatial understanding of one of the most commonly and widely used, the Pythagoras theorem. To know about the Pythagoras theorem, you have to first know what is the statement of the theorem. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Mathematical formula. The mathematical formula of Pythagoras theorem is a square plus b square is equal to c square. A and b are the perpendicular sides of the right angle triangle, whereas c is the hypotenuse or the longest side of the right angle triangle. Now I am going to tell you about the applications of Pythagoras theorem in both architecture and nature. A. Applications of Pythagoras theorem in architecture. 1. building design. The architects use this theorem to calculate lengths and diagonals when designing rooms, roofs, and support structures. 2. Structural integrity ensures beams, trusses, and supports form perfect right angles for strength and stability. 3. Staircase construction used to determine the diagonal length or hypotenuse when designing stairs by using the formula rise square plus run square is equal to stair length square. 4. Land surveying helps in plotting buildings and dividing land using right angle triangles for accuracy. Applications of Pythagoras theorem in nature. 1. Tree height estimation. By measuring distance from the tree and the angle of elevation, we use this theorem to calculate the tree's height. 2. Animal movement. Birds and animals often take the shortest path, forming right angle triangles when avoiding obstacles. 3. Mountain slopes and river beds used by geographers and environmental scientists to measure inaccessible areas indirectly. 4. Beehive geometry. The bees use efficient spatial patterns including right angles in hive construction connected to the Pythagorean principles in space optimization. Now I'm going to tell you some fun facts about Pythagoras theorem to boost your energy and mind. 1. Older than Pythagoras, the Babylonians and Indians knew about this theorem. Okay. The Babylonians and Indians knew about this theorem centuries before Pythagoras lived. Summary. In conclusion, Pythagoras theorem is not just a classroom concept. It helps us to build, navigate, measure and design our real world environments with accuracy. Thank you. Now feedback.
Good morning everyone, my name is Vijaydeep from grade 4 Lilac, and today I am here to discuss with you an important aspect of everyone's life, money. Let me take you through the various stages of evolution of money. Barter system. Bartering is an old method of exchange of goods which was introduced by the Mesopotamian tribes before money was invented. Advantages. Goods were traded for a completely different item. Exchange was not only for goods but also for services. Disadvantage. There is no proof or certification of service or item exchanged. Cowrie shells as currency. Cowrie shells are small, portable and durable. They are served as excellent currency, almost impossible to counterfeit it. Disadvantage. Lack of uniformity, limited divisibility and large amounts cannot be carried. Coins as currency. Here, coins can be traced back to the ancient civilization where small discs were used as a medium of exchange which evolved in size, shape with time. Paper currency. As trade expanded, larger denominations and portable currency arose. Disadvantage. Large amounts carried. Though paper currency is known as the most safest transaction, it is difficult to carry in large denominations. Notes are counterfeit. Excess usage of notes can lead to soilage. Debit card, credit card. Credit card. Inception of credit card can be traced back to the ancient civilization where merchants extended credit to customers based on trust. Debit card. We can withdraw money from the nearest ATM or use it straight in shops and malls. Cryptocurrency. Cryptocurrency are digital tokens which allow people to make transactions through online systems. Example, Bitcoin and Avalanche. Thank you. Thank you, ma'am.
Good morning, ma'am. This is Trisha along with my companion here to present our model for SOLVIMANIA.
So why to delay?
Let's begin.
Risha, do you know why we have gathered here?
Oh Manogna, I've already told you in the starting that we have gathered here to present our model for SOLVIMANIA.
Oh, I see. Silly me.
Yeah. Okay, now let's talk about competitive swimming.
Competitive swimming generally takes place in 25-meter short course and 50-meter long course swimming pools. The standard unit for Olympics are the major international events. Swimming competitions are held in various distances and strokes, including freestyle, backstroke, breaststroke, butterfly, and medley, which includes all 4 strokes.
That's right. Key aspects of competitive swimming. Events. Individual events including in various distances, example 50 meter, 100 meter, 200 meter, 500 meter, 800 meter and 1500 meter. Training. Competitive swimmers train extensively to build endurance, strength and technique. Medley. It includes all 4 strokes. Guys, do you know who is the greatest swimmer of all time? Who is the greatest swimmer of all time? Ma'am, the answer is on our trifold chart. Can you guess? Yeah. Ma'am, you can treat yourself with a chocolate if you like.
Michael Phelps is regarded as one of the greatest swimmers of all time. He with a record of 28 Olympic medals and 23 gold medals. He is born in Baltimore, Maryland on June 30, 1985.
He started swimming at a very young age and joined the North Baltimore Aquatic Club where he was trained with Bob Bowman.
Here are some riddles to entertain you guys. Whoever tells the right answer wins a chocolate.
I'm often seen in competitive swimming pools. I help swimmers stay afloat. I'm a swimming pool accessory. Who am I? I'm often seen in competitive swimming pools. I'm a pool accessory. I help swimmers stay afloat. Who am I? No, ma'am. I help swimmers stay afloat. Yeah, yes, ma'am. Like it's similar to a tube.
They'll hold it, they'll kick it.
Yes, ma'am.
To move forward.
Yes, ma'am. Nice try, ma'am. The answer is a kickboard.
I'm a swimming stroke generally used in Olympics. I'm not that fastest, but my name is similar as a butterfly. Who am I? The correct answer is butterfly stroke.
Ma'am, you might be wondering how math is involved in the swimming pool.
For a rectangular swimming pool, the perimeter is 2 into L plus B and area is L into B.
It also includes calculating pool dimension and area, determining water chemistry and treatment, and building a swimming pool.
Thank you guys for your cooperation. I hope you liked our projects. Until then,
me Risha,
me Manongna,
signing off.
Good morning everyone. In a world where security is no longer a luxury but a necessity, we often face threats that are constantly evolving. Traditional defenses often fall short, leaving our homes, businesses and critical spaces vulnerable. But what if protection could be silent, invisible and incredibly precise?
Today, we unveil the Laser Guardian, a cutting-edge laser beam security protector. This isn't just an alarm, it's an invisible maze, a vigilant sentinel that stands guard without ever being seen. It works by projecting an undetectable laser beam across a protected area. When this beam is broken, even by the slightest intrusion, an immediate alert is triggered.
At its core, it's simple. A laser emitter, a receiver and an alarm. But the true genius is the unseen force that transforms this simple concept into a sophisticated guardian, lies in the universal language of innovation. Geometry, algebra and calculus are not just the chapters in the textbook. They are the very DNA of the Laser Guardian working in a perfect harmony to ensure our safety. Let's reveal how.
Our first guardian is geometry. Think of a laser beam as a perfectly straight path of light, a pencil beam. Geometry allows us precisely to control this path of light. To protect a larger complex areas, we don't use just one beam of light. We create an invisible maze.
We use mirrors strategically placed to bounce the laser beam around corners, across rooms, and through doorways. The fundamental rule here is simple. The angle at which the mirrors will stand to create integrates crisscross rays of laser beams.
Before conclusion, we would like to show you our working model. Yeah. Just a minute. When you put your hand in between, it produces a light. Actually, I'm not able to see the idea. Yeah. Like that. Ma'am, actually according to the project, whenever you put your hand in between, it analyzes the Yeah, actually I was not able to see the LDR because I was not there, right? Here you have a clear view of LDR. Whenever the light enters the LDR, it stops producing sound. And when you put your hand in between like this, it starts producing sound. It is a very good protection tech nowadays in the market because it is very precise first of all. And it is a very loud beam and you'll get to know what is happening. And you'll have a camera installed as well. So it will be very useful for you. And all of this is all because of math. So that's what is our project. Thank you, ma'am.
Thank you, ma'am.
Good morning, sir. My name is Rudranath from grade 7 Lilac. Today I am going to represent my project as Math in Life. Math is calculations, and these calculations are a vital part of our life. These calculations are started even before when we are born in our mother's womb. These are done by radiologists by using ultrasound machine. My math project will help you to understand and predicting the fetal development, like fetal growth starting from one cell to many cells, and the heartbeat. Early stage. In the early stage, there is a round ball-like structure called the yolk sac. From 6 to 12 weeks, the doctors will check the CRL, crown to rump length. Here you can see the CRL picture. The CRL is measured in mm. In 6 weeks, it's 4 mm. In 7 weeks, it's 11 mm. Till 14 weeks, it's 81 mm. From 9 to 12 weeks, the fetus is called as a baby and the head starts to form. Here we can hear the heartbeat clearly. The heartbeat is calculated in BPM, beats per minute. From 13 to 27 weeks, the doctors will check the longest bone in the body, the femur length. From 28 to 7. From 28 to 40 weeks, the doctors have to check the abdominal circumference and the head circumference. Here you can see the graphs. The percentage should be less than 95% or more than 50%. If it is less than that or more than that, it is called as it is in danger. After the baby grows, the doctors will check the weight of the baby with the weighing scale. It should be more than 2.5 to 3 kgs. If it is less than that, it is called as low birth weight. Thank you. Sir.
I'm from grade 4, Aster. Today, let's learn about math in aviation. Welcome to Math Airlines. It's time for takeoff. Wait, before I take off, I just don't press the buttons and zoom off into the sky. I check everything carefully using math. First, I check the weight of the plane. Today, we carry about 100 passengers. Each passenger can carry 15 kg of luggage. Can you tell me how much is 100 into 15? Can you tell me? Is 100 into 15? That's 1,500. Math helps me balance the plane so it doesn't tilt. Next, I check the time. If we leave at 10 am and the flight is 2 hours long, when will I reach? Can you tell me what is 10 plus 2? That's right. Math helps me plan and be on time. Next, at last, I check the distance. Today we are flying from Hyderabad to Delhi. That's an 1,500 kilometers at a speed range of 500 kilometers per hour. Can you tell me how much is 1,500 divided by 500? Yes, that's 3. So it's 3 hours long. Math helps me land on time. And I check the windsock. This is a windsock. Windsock shows the wind direction and speed. And of course I talk to the ATC. This is the ATC. ATC are called air traffic controllers. They help pilots land and be on time. I say that flight 101 is requested to take off at runway 18. They say climb 15,000 feet, pilot. I say climbing to 15,000 feet, Roger. Next, here, this brain crash due to miscalculation of math. Gimli glider, Air New Zealand, Air Jupiter and Air Midwest flight. The planes crash the miscalculation of math. Here I want to conclude that all planes need math. Without math, planes couldn't fly. So next time, remember that math is always flying with you. Thank you. You know from grade 3 to left. Welcome to SOLVIMANIA. I am a time traveler. Today I am going on an amazing journey through the time and different countries to find out how numbers were born and how they changed. Let's start a journey. Wow, I'm in ancient Egypt. The people here use pictures to count. They draw a line for 1, a heel bone shape for 10, a spiral for 100. Egyptians used numbers to build pyramids and countings. Now I'm in ancient Greece. The Greeks use their alphabets as numbers, like alpha A means 1, beta B means 2, and so on. They learned math and geometry, like the famous Pythagoras. Now I'm in ancient Rome. Romans used Roman numerals like I for 1, V for 5, X for 10, L for 50 and C for 100. They wrote numbers on buildings and coins. Even today, we see Roman numerals on clocks and movie credits. Now, I'm in ancient India. Guess what the Indian gave the word zero? Yes, a big invention. They have the place value system like ones, tens, hundreds. This made maths much easier. Now, I'm in Arab world. The scholars here learn from Indian numbers and spread them. They have the word used 1, 2, 3, 4. The number we use today, that's why we call them Arabic numerals. And I'm back. Numbers are like magic. They're everywhere. Thanks to Egypt, Greece, Rome, India and Arab for the journey. Numbers are old, but they're still our future. Thank you.
Before we conclude this wonderful celebration of math, let's unite in honoring our nation. Our national anthem is not just a song, it is the heartbeat of our country, the spirit of unity that binds us all. I request everyone to please stand straight for the national anthem.
You know what is this shape? It is a circle. It is round in shape just like on the wheel. Circle is the shape that goes round. Circle is the shape that goes round. Circle is the shape that goes round and round. Circle is the shape that goes round. I have 4 equal sides. 4 is a square. 4 of them is a square. Good morning. Good morning, sir.
Yeah, good morning. Good morning.
Ma'am, you know what shape is it?
No, I don't know.
Okay, tell you it is a rectangle. It has 4 corners and opposite sides are equal. Rectangle, 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 I see. Count the points, count the sides, count them 1, 2, 3, 4. Thank you.
Good morning.
Morning, Uncle and Auntie.
Sir.
Do you know what shape it is?
Circle, right? Circle only, na?
No, oval shape.
Oh, oval shape, okay.
Okay.
Yes, no size, no corner. It's an oval. Oval like an egg, and oval like an egg. I know that there is oval like an egg. Thank you.
What is that shape?
Triangle.
Okay.
Good morning, sir and ma'am. Do you know what shape is this? Good morning, sir and ma'am.
Yeah, tell me.
Yes.
What is it?
This is a triangle. It has 3 sides and 3 corners. Triangle, triangle, triangle. I see. Corner, 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 sides, corner, 1, 2, 3. Thank you. Thank you. Good morning, sir and ma'am. Do you know what comes before 7? I will show you. It's 6.
That is 6, sir. Okay. Next, after that?
Hello, ma'am. Hello, sir. Do you know what comes before 4 and 6? I will show you. It's 5. Hello, ma'am. Hello, sir. Do you know what comes after 6? I will show you. It's 7.
Very good.
One value smaller than the other value. Thank you.
Let's see. The equal to?